All right, now we want to finish this section by an overview of the dependency inversion principle. So here's the classic definition of this principle. High-level modules should not depend upon low-level modules. Both should depend upon abstractions. What does this mean? Well, imagine we have a controller that is dependent on a repository. And here I'm talking about a concrete implementation of a repository, not an interface. So in this case, a controller is a high-level module and repository is a low-level module. Okay? Now here we have the violation of dependency inversion principle because high-level modules should not depend upon low-level modules. They both should depend upon abstractions. So how do we solve this problem? How do we apply dependency inversion principle here? Well, we extract an interface from the repository class, call it iRepository. So this is an abstraction. Now our controller should depend on this iRepository interface. Now in this picture, you can see that high-level modules are not dependent upon low-level modules, and they both are dependent upon abstractions. Now you might ask, what is the benefit of this? Why do we use the dependency inversion principle? The answer is to reduce the impact of changes. So back to this original picture. With this dependency between the controller and the repository, anytime we make a change in this class needs to be recompiled, and all the classes that are dependent upon this class should also be recompiled. And this also means the assemblies in which these classes are defined need to be redeployed. Now, with the dependency inversion principle, we can make as many changes as we want in the repository implementation, and these changes will not impact our controller because the controller is not dependent upon this implementation. As long as the interface or the contract stays the same, the controller is not affected. And this way we can reduce the impact of change in our software. Now, what is interesting here is that an interface represents a concept. Here we have the concept of getting a vehicle, adding a vehicle, and removing a vehicle. It's very unlikely that these concepts will change. We always need a way to get a vehicle, add a vehicle, and delete a vehicle. But how we do that can change. So an interface represents the what, whereas its implementation represents the how. So this is dependency inversion principle. However, there is a problem with our current implementation of the dependency inversion principle. Look at the namespaces or the packages in which these classes are defined. So the controller class is defined in the controller's namespace, and our repository interface and its implementation are defined in the persistence package. Now, if you hide the classes in these packages, note the direction of dependency between these packages. We have a high-level package or a high-level module that is dependent upon a low-level package or a low-level module. We need to inverse the dependency using the dependency inversion principle. So we introduce a new package, call it core, and put all the abstractions here. Now you can see the iRepository interface is in the core package. The repository implementation is in the persistence package, and we fully conform to the dependency inversion principle. So high-level modules, high-level packages are not dependent upon low-level modules or low-level packages. They both are dependent upon abstractions. So back in the VS Code, I'm going to create a new folder, call it core. Then I'm going to move iRepository and iUnit-of-Work interfaces in this folder. So persistence/i vehicle repository, move it to core. One more time, iUnit-of-Work also goes to the core package. So this core represents the core of our application. This is the core domain of the application. So all the domain classes also belong in this package. So I'm going to move this models folder inside the core package. Now in the persistence folder, we have 3 classes which provide persistence for our application using Entity Framework. We have Unit-of-Work, DB context, and the repository. If I want to use a different ORM in one or more of my repositories in the future, I can simply add a new class here that implements one of the interfaces we have defined in the core package. And this way, none of our controllers will be impacted. As long as this new repository is implemented properly and it fulfills the contract, everything is good. Now look at the core package. We have iUnit-to-work, iRepository, and the models. So earlier I told you that a repository is like a collection of domain objects. Just like we have the vehicle class in the models package, we also have iVehicle repository, which is like a collection of vehicle objects. So this is dependency inversion principle in practice. Now let's take a look at this iUnit-to-work. You can see the namespace is not changed because currently VS Code doesn't have proper refactoring tools. And when we manually move files using the file system, their namespaces are not changed. This is one of those cases that ReSharper or Visual Studio are better at. So make sure to manually change the package name here. And also we have this ugly package name here, Vigo. It's lowercase, it's not consistent because earlier in the beginning of the course, I used a lowercase name for my folder and that ended up as being the root package name. All right, now I'm going to pause the recording and update these package names. Note that in the vehicles controller, before applying the dependency inversion principle, we were referencing the persistence package. So our high-level module was dependent upon a low-level module. Now with the dependency inversion principle applied, we need to change this to vega.core. This is where we have our interfaces. Now we don't have a dependency upon a low-level module.